Excuse me, this is a video for Advanced Algebra 1, our last section in Topic 1, and solving absolute value equations and inequalities. And just a refresher, absolute value is a number's distance from zero. So when we think of a number line, maybe we have -10, -5, and we want the absolute value of -8. Well, somewhere way over here is 0, and -8 is 8 units from 0. So the absolute value of -8 is 8. The absolute value of +8, 8 is also 8 units from 0, so it is also 8. Distance is positive, and so a number's distance from 0 is positive. So when we go to solve this absolute value equation, we would subtract 2. We want to isolate the absolute value. So 5 equals the absolute value of x. And now I think, what number or numbers are 5 units from 0? And they are 5 and -5. So we're going to have two answers to these questions. When we get into the inequalities, we'll have a graph also on a number line describing the numbers that fit that equation or inequality. When it's an equals, if it's on a quiz or worksheet or something, we don't need to bother with graphing the solution. If it's an inequality, we always, for me, we always have to graph the solution there. So in this one, the absolute value is already isolated. So how do we do this? Well, if I had the absolute value of x equals 1, I would say that x equals 1 or x equals -1. And that's applying the definition of absolute value. So if I have that this stuff equals 1, the absolute value of this stuff equals 1, then this stuff equals 1, or this stuff equals -1. And that's what I'm solving then. So here I would add 3 to both sides. I get 2x is 4. Divide by 2. Do the same thing over here. Add 3 to both sides. 2x is 2. So x is 1. And we can plug them in and check them. If I plug in 1, I get 2 minus 3. That's -1. The absolute value of -1 is +1. So that works. If I plug in 2, 2 times 2 is 4. 4 minus 3 is 1. The absolute value of 1 is 1. So that one also works. This is applying the definition of absolute value. When I apply that definition of absolute value, I say that this stuff inside equals +1, excuse me, or it equals -1. When we get to inequalities, it's a different story. And this is why we studied compound inequalities. So when we have a less than symbol, okay, that means that x is greater than -1 and x is less than 1. Okay, that's how we apply the definition of absolute value to an inequality. When it's a less than, I prefer to write it as we talked about this being a conjunction. It's that type of compound inequality. Okay, so if we have a less than problem, okay, to apply the definition of absolute value, we will write this compound inequality as a conjunction. And so we write -9 is less than or equal to the stuff that's in here. It's less than or equal to 9. It's less than or equal to 9. And I solve that. I add 6 to all three parts. And I get -3 is less than or equal to 3x is less than or equal to 15. And then I divide all three parts by 3 to get x by itself. So -1 is less than or equal to x is less than or equal to 5. Then I graph that inequality. So here's 0, here's 5, here's -1. So I put closed circles at -1 and 5, and x is between them. So we draw in x is between them. Okay. That's how we apply the definition of absolute value to a less than problem. Here's how we apply the definition of absolute value to a greater than problem. If the absolute value of x is greater than 1, then x is less than -1 or x is greater than 1. So what we're doing is we're writing this as a disjunction. It's an OR problem. It becomes an OR problem. And so to solve this inequality, I take the stuff inside, apply the definition of absolute value, I take the stuff inside and I say 4x minus 12 is less than -20, or 4x minus 12 is greater than 20. Set it, write it. And then we want to solve those. We add 12 to both sides here, and I get 4x less than 8, x less than 2. Then I add 12 over here, and I get 4x is greater than 32, x is greater than 8. Then again, number line, and I didn't, well, let me finish. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So less than 2 will be an open circle going this way, and greater than 8 will be an open circle going this way. The number line is part of my answer, but also part of my answer is to say x is less than 2 or x is greater than 8. Just like up here, the number line is part of my answer. The other part of my answer is that x is between -1 and 5. You need both parts to be correct. Really, that's pretty much it. The hardest part of it is this part, and just knowing when to write it with the x in between and when to write two different inequalities. And less than, kind of and than, so I'm writing a compound inequality with and. That's how we do that. Greater has the or in it, so we're writing a or statement. We're writing an or statement to apply the definition of absolute value. And like I said, that's just basically following those steps for whether I have a less than problem or a greater than problem with absolute value. That's how I apply that definition of absolute value. So that's it. All I got.